Solving inequalities using multiplication or division. So our objective for this section is to use multiplication or division to solve our inequalities. So we talked about in the first section basic inequalities. Now in the second section we used addition and subtraction. Now we're going to use multiplication and division. So just like the last section, just as we use multiplication and division to solve equations in chapter 2, we can use multiplication and division to solve our inequalities. Now, there is one very, very important difference about the multiplication property of inequality versus what we did with addition and subtraction with inequalities and what we did with multiplication with equalities, with regular equations. Okay, so let's look at this right here and let A, B, and C be real numbers. Basically, this is going to be the same that if we multiply both sides by a number that is bigger than 0, we keep our equation similar. Okay, so for instance, if I multiply both sides of this equation by 2, we get -4, we get +6, and -4 is still less than +6. However, the big change is when we multiply both sides of an equation by a number less than 0. Okay? Because multiplying by a positive number just makes whatever I'm multiplying bigger. Okay? However, multiplying by a negative number, we can see is going to make the number bigger, but it's also going to change the sign. So if I start with a bigger number here, I'm going to end up with a bigger product or a smaller product if that product is negative. So for instance, when we start with 3 is greater than 1, which is true, if I multiply both sides of this by -2, we get that -6 is one answer, -2 is the other answer, and you can see that from my original equation, the sign changes. And that's where these two properties come into play. So if A is greater than B, then A times C is less than B times C. The inequality sign changes direction. And this only happens when you are multiplying by a negative number or dividing, and we'll get to that in a little bit. Okay? So here's how this works looking at this example again right here. Okay? So we have 3 is greater than -1. When we multiply both sides by 2, we leave this blank for a second, and I can see that after I simplify, that -6 is less than -2. We're going to have to reverse the inequality symbol to make the equation true. Started with greater than, ended with less than when I multiply by a negative number. Now, that doesn't mean just because there's a negative number in the problem we have to do this. It's only when we're multiplying both sides. For instance, when we solve this equation right here, I have x over 3, which means x divided by 3. So in order to solve this, I'm going to go x over 3 is less than -2. I'm going to multiply both sides of this equation by a +3. Those cancel out, and I have that x is less than -6. Okay? So my answer here did not change, or my inequality here did not change signs. Okay? That's because I'm multiplying both sides by a positive number. Even though there was a negative in the problem, as long as I multiply by a positive number, as long as I multiply both sides of an inequality by a positive number, I'm going to be able to keep the sign the same. Okay, if I wanted to graph this, -8, -7, -6, -5, -4, -3, whatever, open circle, and my inequality is going to go to the left, that direction. Let's try a got it problem. Okay. So what are the solutions of c divided by 8 is greater than 1/4? So to solve this, I take c over 8 is greater than 1/4. I multiply both sides by 8. Those cancel, and those can reduce to 2. So 0, 1, 2, 3, 4. Okay, open circle at the 2, and my answer goes to the right. I'm multiplying each side of this equation by a positive number, so I do not change the inequality symbol. Now for this one, now I'm going to multiply both sides by a negative number. Okay, so negative 3/4w is greater than or equal to 3. To solve this, I'm going to have to multiply both sides by the reciprocal, so negative 4/3. And now, because I'm multiplying both sides by a negative number, now I flip the sign. Okay, those all cancel, and we have w is less than or equal to, the 3's cancel, negative 4. Solid dot, because it says or equal to, and we're going to go to the left. Okay. This is where you have to be careful. Okay. When we multiply these, you got to make sure that you are flipping the sign. And of course, if we wanted to, we can check like we did in the last lesson. Okay, we can plug in any sort of number that we want. Easiest thing to do is plug in 0. So when I plug in 0 in for w, 0 times negative 3/4 gives me a 0. Is 0 greater than or equal to 3? And that is actually true. Oh, sorry, that is false. So 0 is not greater than or equal to 3, and you can see that 0 is not part of my solution. Okay, so my graph makes sense. Try I got a problem. So same thing, which of course, with this problem, if I wanted to, I could represent it like negative 1/3 times n is less than negative 1. If I wanted to change this to a fraction, or I could multiply both sides by negative 3. Or I'm going to do that anyway. Multiply both sides by negative 3. Cancel those. Cancel those. And we have that n is greater than a positive 3. Okay. Now let's put 0 in there. Okay. We're going to have an open circle, and we're going to go this way. And if I were to plug in 0 into my original equation to test this, 0 would be less than negative 1, which again is not true, and 0 is not included in my solution, which goes to the right. Okay. Solving inequalities using division is similar to solving inequalities using multiplication. If you divide each side of an inequality by a negative number, you need to reverse the direction of the inequality, just like we did with multiplication. So my division rules are similar. My division property of inequality is similar to the multiplication property of inequality. Still, whatever I do to one side, I must do to the other side. That rule never changes. Okay. However, if C is positive, the inequality stays the same. If C is negative, the inequality changes from greater than to less than, from less than to greater than, and of course, the same thing with or equal to. Okay, so here in these two examples, we're dividing by a positive number. Here in these two examples, we're dividing by a negative number. Okay, so you can see the signs change direction. Let's take a look at this. You walk your dogs, or you walk dogs in your neighborhood after school. You earn $4.50 per dog. How many dogs do you need to walk to earn at least $75? So let's define our variable. D equals number of dogs. D, dogs. Good letter to use. So let's relate these two things. And we're going to figure out the cost per dog times the number of dogs is at least the amount that you want to make. So the cost per dog times the number of dogs is at least. That means the smallest amount of money you want to make is $75, which means we're going to use greater than or equal to. Okay? So to solve this, we're going to divide both sides by $4.50, and we get that the number of dogs is going to be 16.6 or 16.7 when I round up. Now, we can't walk 0.7 dogs, right? That doesn't make sense, right? So I could round down or round up, right? 7 is closer to round, that would suggest to round up. But let's think about this for a second. Oh, sorry. And it's not equal to, it's greater than or equal to. Since we don't have an actual equality, we have an inequality. Okay, so I want to make at least 75 bucks. If I only walk 16 dogs, okay, I'm only going to make 72 bucks. So in order to make more than 75, in order to make at least 75, the answer is going to be 17 dogs, right? We have to round up so I can make the amount of money that I want to make. Let's try a guided problem. Oh, okay. And that's part B. That's what we're talking about in part B. Why do you round to the greater number? Because, right, we only would make $72 if we didn't. A student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. The club can spend at most $50 for this project. So let's use a variable of V for vegetables. So we're going to do 1068 times V at most. That means that this must be less than or equal to 50 because I cannot spend more than 50 bucks. That's all I have in my account. Okay, divide by 1068. And we see that V, 1068, is going to be 4 less than or equal to 4.68. So if I were to buy 5 cans, even though this is 6.8, you would think maybe round up. If I were to buy 5 cans, I would spend too much money. Okay? So I have to spend only 4 cases. Okay? Or I have to buy only 4 cases. All right. And then dividing by a negative number, a plain equation, we can solve this very easily. We just divide both sides by 9y, by negative 9y. And of course, we remember to flip the inequality symbol if we're dividing both sides by a negative number. And then my rules don't change. A positive divided by a negative is still a negative. 8, negative 7, negative 6. And this is going to be a dot, and it is going to go to the right. If I wanted to check this, just like I've done before, I could plug in 0, okay, which means that 0, that 0 times 9 is 0. Is 0 less than 63? Yes. And you can see that 5, negative 4, I don't think I, negative 3, negative 2, negative 1, 0. That 0 is part of my solution, right? The inequality line is going towards 0 and covering up 0 to include it in my solution set. Okay. My got a problem? Again, very simply, divide both sides by -5. My rules of division do not change. -10 divided by -5 is a +2. The only thing that changes is to be sure that you reverse the inequality symbol. Okay? And open circle this time to the right, to the left. And if I wanted to test, 0 is greater than -10. And yes, 0 is part of my solution right there. Okay? So our lesson check, match each inequality with its graph. Well, if I wanted to solve these things, I could do so fairly easily. One would be D, when I subtract 2 from both sides. 2 would be B, when I multiply both sides by -3 and change the direction of the inequality sign. 3 would be A, when I add +4 to both sides. And 4 would be the last one, would be C, when I divide both sides by a -3 and change the direction of the inequality symbol. Which operation would you use to solve the inequality? With this one, I would multiply both sides by -2, remembering to change the sign. This one, I would add 4 to both sides. I do not change the sign for addition or subtraction. However, I would change the sign for this one because I'm dividing by a -6. Describe and correct the error in the solution. Well, you can see the same thing that we've been talking about all this time is that as soon as you multiply by a negative number, you must change the inequality symbol. Okay? And that is 3-3, solving inequalities using multiplication or division.